Welcome to the Trend Detection Podcast, powered by Siemens.
Hello, welcome to Trend Detection, the podcast where we discuss all things predictive maintenance. I'm your host, Emily Johnson, and today we're joined by Rob Russell. We're here to discuss Senseye Predictive Maintenance's AI attention engine and how it's redefining efficiency for asset managers. So welcome, Rob. Thank you for joining us today. So before we begin, would you like to give us a short intro about yourself and your role at Siemens?
Yeah, hi. My role at Siemens involves overseeing the predictive maintenance strategy for our Senseye Predictive Maintenance product. But in addition to that, I'm responsible for helping to support and scale our delivery capability across all regions.
Well, that's brilliant. Thank you for that intro. So for those unfamiliar, can you explain the core mission of Senseye Predictive Maintenance and the value that it brings to asset managers in particular?
Yeah, so at Senseye, what we're trying to do is scale out the ability to use condition monitoring data to drive reliability engineering. And it's using technology to scale any skills that we have within reliability engineering within customers' organizations. But we underpin this with key focus on helping aiding decision making and becoming a decision support tool fundamentally.
No, that's great. And I can imagine, obviously, decision making, especially in industries with vast assets, is always challenging. So can you shed a bit of light on how Senseye PDM prioritises efficient decision making for its clients?
Yeah, so the core of our product, it's in and around detecting unusual behaviour within machines and assets. But just pointing people to that unusual behaviour on its own can actually lead to an overwhelming sort of flow of alerts and insights. We learnt that very early on. So what we needed was a way of actually minimising the amount of detections and notifications going to the user. And we created what we call our attention engine. And this uses what's called an attention index. But this is an AI capability that's trying to understand what the system believes the user will be interested in applying their focus to on that day, as opposed to trying to come up with some sort of arbitrary health score or something for an asset. It's more about how the user should be interpreting the data and which asset they need to give attention to that day than when they turn up to work.
So this leads on to my next question. So most asset managers have to constantly be on top of asset health or risk. How does Senseye PDM's technology alleviate these daily concerns and make those day-to-day operations a little bit smoother?
Yeah, so by using the AI technology that we have that helps us to really understand and get feedback from the user and build that into this attention engine that we've been talking about, what we're doing there is we're moving away from the case where users need to look at risk indexes or health examples within an application to having a solution that understands their needs on a daily basis, but trying to simplify this down into something that people don't actually need to worry about the underlying AI and machine learning technology, because our end user is a maintainer. He just wants to get an answer, have something that can support his decision making, and then get back to his day job of maintaining and fixing the machines.
No, so that's great. Thank you. So what you've said links into the fact that we're in a digital age with an overwhelming amount of information. So how does this information overload impact the traditional role of an asset manager?
Yeah, so with the sort of connected and digital world that we're in, there's so much more information available. It's several orders of magnitude more than it maybe was a couple of decades ago. And if you're using traditional sort of methods of condition monitoring and reliability engineering, you're just going to get overwhelmed with false alerts and spend your entire life probably adjusting thresholds in existing and traditional systems. So really the focus is appreciating the fact that as we move into this digital age, or if you want to call it an industrial Internet of Things, the way to scale isn't to scale humans. The way to scale is actually scale with technology and make sure you can actually leverage the best capabilities that humans have. So take away all the mundane stuff, get the technology doing that, and have the humans focus on the things that's really hard to get technology to do, like interpreting the results of the output of a system, doing a fault investigation on a machine, and really getting to the root cause of the problem and solving that.
So Rob, can you tell us more about how does technology, and specifically AI, play a part in extending human capability in asset management?
Yeah, so with the vast streams of sensor data that are coming into machines, what we've tried to focus on is creating AI capability that is more enhancing the things that a human would normally do. So you'd be able to look at some data on a chart and detect, and maybe you pick up a trend or there's some spiky behaviour. You probably look at it yourself and say, well, I could have looked at that and told you something was wrong. But now the challenge comes is you've got 10,000 of those data streams coming in at you every day. You don't have the time or the capability to actually look at those in your day-to-day life. So we've created technology that understands what it is that you will find interesting within that data stream, and then tries to mimic that understanding that you would have, look for that characteristics in the data, or we call them patterns. And then once those patterns are sort of marked up in the data, then we can start allowing the system to make decisions about how significant they are, those patterns, and how interested you'll be in them. And then that's how we can start to decide what to put in front of you today, maybe what to hold back on, not tell you about, let some more data come into the system, and then maybe tomorrow you'll get a notification about that machine.
That's a great answer. Thank you, Rob. So moving on, the main topic that we're speaking about today is the Senseye Predictive Maintenance's solution, Attention Engine. So can you shed light on what this is and how this is actually driven by artificial intelligence?
Okay, so the underpinning technology within that Attention Engine builds on things that, I'm a mechanical systems engineer that I'm not an expert on, but typically like things like neural networks and typical sort of machine learning and AI capability. But at its core, it performs two main tasks. It's looking at these patterns that we were talking about earlier, but then it's also trying to absorb input from the user, and that input could be various types of context. Maybe there was some maintenance action happened recently. There might have been a similar type of detection that happened in the past, and there was some negative feedback provided on that. So it can build up this feedback that it gets from the user, other contexts of things that might have happened to the machine, and then it brings that all together, and then it's making decisions about which parts of the data to escalate up to the user to bring them in to look at. And again, as it goes through that process, the workflow within the application is sort of soliciting more feedback from the user and more interaction. So on day one, it has a certain level of capability that the users will experience. As we go forward in months and years ahead, with the interaction of the user, the system just becomes richer and richer, and hopefully becomes more precise in the type of notifications that it's sending to you.
That's great, thank you. So we know that there are other products on the market currently that offer a similar product value to Senseye Predictive Maintenance. Can you shed a little bit of light on what makes Senseye Predictive Maintenance different to other products on the market currently?
Yeah. I think from our perspective, it's fundamentally that focus on attention and what the user is interested in. The majority of products, and actually where we started, was trying to really understand something like an overall health score for the machine. But we realised that wasn't achievable. You'll never really truly know the health of the machine from sensor data that's on there. But we realised that once we broke that paradigm and we said, let's stop worrying about trying to understand the health of the machine. Let's just worry about what we want to get in front of the user on a day-to-day basis. That allowed us, from our research and our product development, to take an entirely different approach. And I've not seen another solution out there that really takes that direction to it. Most things are looking at health scores, risk scores, and this sort of thing, as opposed to focusing on what is it that the user really needs to know today.
So thank you, Rob, for giving us a little bit more information on the Senseye Predictive Maintenance product. So what would you pinpoint as the main benefits for a busy asset manager?
Yeah, so if you're an asset manager responsible for hundreds of machines in a factory, you're probably trying to direct and maintain various members of your maintenance team, come up with maintenance plans and maintenance schedules. And what you need is a source that can give you some information to help you with those decisions. So as well as having to plan in, all your preventative and scheduled maintenance, you also want to be able to supplement that with maybe opportunistic pieces of work. You might know that you're going into a period where there's going to be a pause in the production process. Having information from Senseye, maybe we can say this machine's becoming a little bit more interesting for you. You could use that opportunity to go in and start to intervene and then not have an impact in the production process. Because there's always a tension between reliability engineers and the production managers. The reliability engineers are wanting access to the machines. Production managers don't want to stop them. They want to keep the machines running and and doing what they're supposed to do and generate outcomes and benefits for a business.
No, that's great, thank you. And then in terms of human support, what can clients expect in terms of having hands-on support with, actual team members? Because in a world of AI, that's something that a lot of people, would still like to have. So what would you say that, the Senseye Predictive Maintenance team can offer in terms of that type of real-life support?
Yeah, and that's a really key aspect in what we do, because we appreciate that, technology is hard, but actually changing businesses and cultures and ways of working is even harder. So we've got our underpinning technology, but we realise that just delivering that on its own doesn't impact or create change. So we've got our Senseye Knowledge platform and our core methodology that we use, along with our delivery capability and our customer success management. And we're always there with the customer, and as much as they sort of need us to ensure in those early days they're understanding how to make the best use of our system, but also gaining some sort of insights and ideas as to how to adapt and change their maintenance strategies and integrate our solution into their wider sort of asset management tool suite.
So Rob, I'm sure you can imagine that concern for many is the seamless integration of tools into their existing workflows. How does the Attention Engine fare in terms of integration compared to other solutions in the market?
Yeah, so at Senseye, we've always appreciated and understood that the problem we're solving is one part of a wide chain of sort of capabilities that maintenance managers and asset reliability engineers need. And because of that understanding that we're that one piece within an array of systems, we've always maintained an open architecture. And that allows clients to use our data integration points, take data into maintenance management systems, for example. They can use it to maybe inform people that are looking at spares and obsolescence reports, or even just simple things like dashboards down on your production line. So by having that open architecture and using quite well established and well-known cloud-based technologies, it's easy for clients to pull data out of our system and then exploit it within other tools they have.
That's a great answer, thank you. And can you give a little bit of light on how long a typical deployment takes? I know it kind of varies from company to company, but can you kind of just shed a bit of light on what the typical timeline is for a Senseye Predictive Maintenance deployment?
Yeah, so typically what we'll start is, even like pre-contract, there's a whole series of activities that we'll want to do to discover with the customer what is the key challenge that they're trying to solve. And with predictive maintenance, it might not be the obvious one, like avoiding downtime. It might be trying to reduce the amount of maintenance that's carried out. So that can take, a period of weeks and to build up that understanding. Then once we sort of move into the state where we're starting to really kick a project off, some of the issues come with aspects related to connectivity. As I hope maybe the audience know, Senseye is a cloud-based application. So we've got to figure out how do we get the data from the shop floor to the cloud and do that within the realms of security that customers have. And we've got various solutions within Siemens that I'm starting to think of as like Senseye-ready capability. So whether this is software gateways, edge capability that are already there that can talk to these shop floor protocols, but importantly, can communicate in a secure manner to the Senseye cloud and push that data. What that means from a timeline perspective is, the answer is it depends, right? So it depends on how mature and the customer infrastructure is, but it could be anywhere from a couple of months to get the project up and running, to sometimes it takes a little bit longer, where we're having to work closely with the customer and provide them a lot of support in deploying hardware and software solutions. But typically what we try to do is set up an initial deployment project of anywhere from 6 to 12 months. Because in a lot of the early stage projects, what you're trying to do is actually get the evidence and the proof points of the value. So it's more of a proof of value rather than a proof of concept. I tell people that with Senseye, the concept's proven. What we've got to do is demonstrate how that can be taken and prove value for you as an organisation.
Yeah, so thank you, Rob, for that answer. That was great. So as we look to the future of asset management, how do you envision AI, and how do you think that Senseye Predictive Maintenance further evolves or reshapes the landscape of predictive maintenance and asset management?
Yeah, so there's many opportunities coming out. As everybody be aware, there's a lot of excitement at the moment in and around things like large language models and generative AI. One of the things that we are very interested in is starting to think beyond the sensor and the time series data that we're looking at, and thinking how can we actually leverage a lot of the text-based information that we can get from users. So we're exploring ideas about how to get more interaction from users and more sort of text and based information into the app, that then we can start to come up with more prescriptive outputs. So if you think what we've achieved is we've taken clients from regimes of like preventative maintenance now into predictive maintenance, where sort of the next natural evolution of that is actually the system now being able to prescribe what should be done. And these are some of the things that our research team are looking at that are, I feel, quite exciting, and looking forward to seeing some of the output of those.
That's great, thank you. And that kind of leads us to the end of this episode. Would you be able to give the listeners 3 key takeaways from this topic?
So 3 key takeaways then. So what would say? So first one would be thinking about the using technology to be able to scale the human role within asset reliability and predict and maintenance. So what that means is not solving the problem with huge teams of people, but actually using really smart technology to help the people that you have that are your existing experts. Maybe the second one is ensuring that you don't overwhelm or sort of saturate people with lots and lots of notifications. So you need a solution that can actually learn from the user and what they're interested in and adapt and change over time. And then the final one is ensuring that you can actually scale the connectivity aspect of it. So, and this is where it's very important that when you go in to actually connect up to machines and you're looking for the right type of data, we're really focused on getting the right type of like pre-processing and edge processing, but in a way that doesn't require, huge teams of automation engineers to roll solutions out, trying to leveraging what already exists and making the most of that.
So I guess that wraps up our discussion today on the transformative power of AI in asset management, particularly through Senseye Predictive Maintenance's attention engine. So thank you for joining us, Rob.
Thanks for having me.
To find out more about Senseye Predictive Maintenance, click the link in the description below. Thank you very much for joining us, and we'll be back again very soon. Goodbye.
Please like and subscribe on all major podcast channels, and find out more about Senseye Predictive Maintenance at Siemens.com.